Good afternoon and welcome to Sheet 9 in this live stream series. So we're going to be starting off with question 1, which is quite a tricky one to start with. It's going to be at least 5 minutes, so I'll give you the maximum 5-minute time that I have and see how you get on with that and go through the answer afterwards. Off you go. To give you a fighting chance of getting this done in the 5 minutes, you need to know that sin x plus cos x is a factor of sin cubed x plus cos cubed x. Sin x plus cos x is a factor of sin cubed x plus cos cubed x. One minute to go. Right, so this is a tricky one to start off on a Monday afternoon. And so we're going to find an expression for dy by dx for this thing here. Well, seeing as it's going to have all these sines and coses in it, why not? Let's just write this as cos x all to the minus 1. And this as sine x all to the minus 1. And we could do this using, I'm going to do this using the chain rule. You could use the quotient rule. You could do it however you like. Anyway, cos x goes to sine x. So I'm going to differentiate that. This is going to come outside of my function. And then I'm going to have the minus 1. So I'm going to put a minus there for the minus 1 coming down. And I'm going to times and raise that to power of, take 1 off that power, which will give me cos x to the minus 2 using the chain rule in my head here. Oh, and cos goes to minus sine, so actually I'm going to get a minus as a minus, which will give me a plus. Nearly made a mess of that. Sine x goes to cos x, and I'm going to get a minus 1 times that minus gives me a plus, so I'm going to get a cos x outside the bracket. Inside the bracket sine x, take another 1 off that power, gives me that to the minus 2. So I get sine x over cos squared x plus cos x over sine squared x. And we need to try and write these with a common denominator. So I'm going to times top and bottom of this by sine squared and top of the bottom of this by cos squared. So I'm going to get sine x cos squared x plus cos x, no, sorry, wait, top and bottom of this one by sine squared. So I've made a mistake there. Sorry about that. Start again. So top of the bottom of this by sine squared gives me sine cubed x over cos squared x sine squared x. And then top and bottom of this by cos squared will give me cos cubed x over that. And that gets us exactly what we want. Hence, so the curve of stationary points when tan x equals minus 1 or sine x cos x equals 1. So what we're going to do is, therefore, if this is going to be equal to 0, then sine x cubed x plus cos cubed x must equal 0. Okay, and we're going to take out a factor of sine x plus cos x, as I hinted. And we're going to need sine x times the sine squared x in here. And we're also going to need a cos x times a cos squared x in here. And then in the middle, we're going to need a minus sine x cos x. Okay, to get what we need, because we're going to get, from this, we're going to get cos x times sine squared x. So therefore, we have this times sine x, we'll get a minus sine squared cos x to cancel out with that. And from here, we also get a cos squared x times a sine x. And we want this times that to cancel out with that. So therefore, either sine x plus cos x equals 0, or we get sine squared x minus sine x cos x plus cos squared x equals 0. So from here we can therefore get sine x equals minus cos x. Divide both sides by cos x, we get tan x equals minus 1, is what we wanted to show. Over here, cos squared plus sine squared is 1, so we get 1 minus sine x cos x equals 0. So therefore sine x cos x equals 1. Take that to the other side and you end up with that equaling 1. So from this one we can see that if we were to draw a little tan curve, I'm going to draw it down here and so on. We're dealing between 0 and 4 pi, so let's go a bit further on. So there's pi by 2 pi, 2 pi, 3 pi. So we're going to go on a bit here. And tan x will equal minus 1. The first one we're going to have is going to be at 3/4 pi. And the next one's at 7 pi by 4, because tan repeats every pi. And then the next one, 11 pi by 4. and then 15 pi by 4. There's no need to go further because further will take us past 16 pi by 4, which is 4 pi, our top value. Now from this we can see that half sine 2x is equal to 1. So sine 2x must equal 2, and that has no solutions, because it's impossible for sine of anything to equal 2. So all our answers to the stationary points are here. So those are all the x values. We can put them back in to find the y values. I'm not going to do that now because we'll run out of time, because all you've got to do is take 3/4 pi, plug it into sec x cos x, cosec x, which is 1 over cos x and 1 over sin x, and work out the y values to get the coordinates of the four stationary points between 0 and 4 pi. But we won't do that now because of the time we need to do to get through the stream. So question 2, here we go. How long should we give you for that? I think this should really be a 2-minute question, especially given the questions we've done in recent questions on the streams last week. Okay, time up there. That should have been enough time to have a go at this question. So we've got ants who have this equation for their graph. Okay, so the velocity is given by 25 e to the minus 0.2t. So it's going to start at 25 here. Start at 25 here and go on to here, and we want to work out the maximum height for this. So we're going to integrate from 0 to infinity 25 e to the minus 0.2t dt, and that's equal to, what we're going to do is we're going to have to divide by this, because when we differentiate we must have times by it. So we divide by minus 0.2, the same as times by minus 5. So we're going to get minus 125 e to the minus 0.2t. So that's between infinity and 0. When you put a very large number into this, this will tend towards 0. So we're going to have 0 minus, put 0 into this, e to the 0 is 1. So we're going to get minus 125 here. So the answer is 125. All right, the next question we're going to do is this one. I'm going to give you probably a bit longer. Let me just see. Yeah, I'm going to give you 5 minutes to have a go at this question to start with. I'm just going to give you just another minute to go on this question because it seems to be straightforward for my class. Okay, that should do for this question. So let's go through it. So writing tan x is equal to sine x over cos x. And we want to differentiate this. So let's differentiate sine x over cos x, and we're going to use the quotient rule to do it. So we're going to write u is equal to sine x, and v is equal to cos x. So du by dx is equal to cos x, and dv by dx is equal to minus sine x. So the formula is equal to v du by dx minus u dv by dx, all over v squared. So v du by dx, so cos x times cos x is cos squared x. U dv by dx, that's going to be sine x times minus sine x, and minus and minus gives me a plus, all over v squared, which is cos squared x. And cos squared plus sine squared is 1. So that gives me sec squared x. Similarly, we can work out d dx of cot x. I won't do quite so much detail. Well, I'll do a little bit of the working. So cot is equal to cos x over sine x. We just got to realise, actually, I'm writing these the other way around. So cos is my u, and du by dx is sine x, and v is my sine x, and du by dx is going to be cos x. Might be what, and so therefore we differentiate that. We're going to get v du by dx. So my v is now going to be sine x, and my du by dx will be minus sine x. I'm going to take away from that my u dv by dx, and my u is now going to be cos x, and my dv by dx is going to be cos x, all over v squared, which is going to be sine squared x. So I have sine x times minus sine x gives me minus sine squared x minus cos squared x, all over sine squared x. Now this is just minus sine squared plus cos squared, which is just minus 1, all over sine squared x, which gives us minus cosec squared x. Right, nice little Newton's law of cooling problem. Let's see, let's give you, I think this should be doable in about 3 minutes. Let's see if you knock this one off in 3 minutes. Right, here we go. So we want to explain what T0 represents. T0 is the temperature here when T equals 0. So it's the 70 degrees. That's what T0 represents. So we're going to do this problem here. Distracted by intriguing puzzle, coffee sits on the desk cooling slowly. Has initial temperature 70 degrees. The room has a steady temperature of 20 degrees. Given that R equals 0.0035, show that after 5 minutes the coffee is roughly at body temperature. So we know that T is equal to the temperature of the environment. T0 minus the temperature of the environment, which is going to be 50. 70 minus 20 is 50. E to the minus 0.0035 times by 300, sorry, the time, 300 seconds. So we type that all into our calculator and we get an answer of 37.5, which is roughly body temperature. Part C. Find the time at which this temperature would take to fall to 25 degrees. So we know that 25 is going to equal 20 plus 50e to the minus 0.0035 t. So we take off 20 is going to give us 5, divide by 50, that gives us 1/10. And that's equal to e to the minus 0.0035 t. So we take natural logarithms of both sides, that undoes the e, we get natural log of 1/10 is equal to minus 0.0035 t. So t must equal the natural log of 1/10 divided by minus 0.0035, and that gives us 657.921 1 decimal place seconds. Let's go on to the next question. Okay, let's see how long we should give you for this one. So we can look at the working you need to do. Okay, I'm going to give you 5 minutes for this one, judging by the working I did to explain this to previous classes. Here we go, 5 minutes. not seeing how to do part A, you need to take this fraction here and split it up using partial fractions. That will help you vastly if you can spot the bottoms of the difference of two squares and split it up using partial fractions. One minute to go. Right, so here we go. We're going to try and split this bit up using partial fractions as our some preliminary work before we get going on this question, because it will help us. So if we write this as a over x plus 1 times b over x minus 1, because x plus 1 times x minus 1 gives us the x squared minus 1. So therefore we know that x plus 7 must equal a lots times x minus 1 plus b lots times x plus 1, because you need to times top and bottom this one by x minus 1, top and bottom this one by x plus 1 to make it the same as this. Now if you let x equal 1, then this will equal 8, that will equal 0, and this will equal 2b, so b will equal 4. And if we let x equal minus 1, then this will equal 6. We get equals to minus 2a, and this will equal 0. So a will equal minus 3. So therefore we have got f of x is equal to 3x over x plus 1 minus, now we've got a over x minus 1, it's minus 3 over x plus 1. And we've got minus all of this, and then we've got b, which is plus 4 over x minus 1. And then we can combine this with this to get 3x plus 3, because you've got minus and minus, over x plus 1. And then we've got minus plus, that's a minus 4x over x minus 1. This is just equal to 3 times x plus 1 over x plus 1 minus 4 over x minus 1. This cancels to leave us 3 minus 4 over x minus 1. Now we want to find the inverse function f of x. Let's just start with this. So let's let y equal to 3 minus 4 over x minus 1. Take away 3. We get y minus 3 is equal to minus 4 over x minus 1. And then we're going to change signs of both sides, because that will make things nicer. So we get y minus 3 equals 4 over x minus 1. And then I'm just going to switch these two around, because x minus 1 will equal 4 over 3 minus y. Add 1 to both sides. I get x is equal to 4 over 3 minus y plus 1. So therefore my inverse function, f minus 1 of x, is going to be equal to all of this, but I replace the y with an x. And that gives me my inverse function. Now I want to write down my domain of this. Now the domain is anything I can put into this that will work. Now the only thing I can't put into this is 3. Because if I do 3 minus 3, I get 0. And you can't divide 4 by 0. So the domain for f minus 1 of x will be x is a member of the reals such that x is not equal to 3. It can't equal 3. And that's that question. So page down, let's go to the next question. This shouldn't take too long. Let's see if you can do this in 2 minutes. Okay, I'm just going to quick look at the last question because I got a question that was interesting. The student asked me if this was the same, what about 1 minus 4 over x minus 3? And I've had minus 4 over x minus 3. You'll notice every single sign is different. So in fact, because you times top and bottom by minus 1, it's exactly the same. So that would work as well. So you could get, if you did get 1 minus 4 over x minus 3, that is also correct. Notice you got minus all of this. If I turn that into plus, I need to make that a minus. Wait a minute, I'm not sure it's the same. Have I made a mistake? I had a minus, I had that, and I took away the 3, I had minus, no, that's correct, it's minus 4 over x minus 1. Make that a plus. Ooh, wait a minute, what have I done here? I've made that a plus. That looks okay to me. Right, let's carry on with this question. So we've got sine 15 will equal sine of 45 minus 30, which when you expand it is sine of 45 cos of 30 minus sine of 30 cos of 45. Sine of 45 is root 2 over 2. Cos of 30 is root 3 over 2. Sine of 30 is a half. Cos of 45 is root 2 over 2. So you get root 6 over 4 minus root 2 over 4, which gives you root 6 minus root 2 over 4. Right, this one to finish off with. I'll give you 3 minutes. It shouldn't take too long to work these out. You should know the period of many of these functions. Let's see if you can work them out in the 3 minutes. Right, here we go. So the first few are quite straightforward. And what we get is, go through all of these, and you could use your graphical calculator to help you on this. So cos of theta we should get every 2 pi. That should be quite straightforward. Now cos of 2 theta squashes up the graph. So if you had cos theta is 2 pi, then cos of 2 theta will actually be pi. It will squash it up, so it'll only take until pi before it repeats. Cos of 3 theta minus pi over 4, ignore the minus pi over 4, that doesn't change the wavelength, but the cos of 3 theta is squashed up by a factor of 3 theta, so of 3, so we do 2 pi divided by 3, and cos of a half theta, well that will stretch it out by a factor of 2, so therefore it's going to double and become 4 pi. Now cos of 2 theta and cos of 4 theta, okay, they're going to repeat every pi. This is going to squash up by a factor of 2. This is going to squash up by a factor of 4. So it will be where they coincide, and that will be at pi, because they're going to both repeat. This one repeats every pi. This one's going to repeat every pi by 2. So therefore they coincide every pi. And this one, you've got cos of half theta and cos of quarter theta. Well, this one's going to repeat every 4 pi, and this one's going to repeat every 8 pi, so they'll both repeat every 8 pi. Cos of 2 theta and cos of 3 theta, they're going to bunch up. This is going to repeat every pi, and this is going to repeat every 2/3 pi, so they will coincide every 2 pi. And similarly here, this is going to repeat every 2 pi, and this is going to so this is going to repeat every 4 pi, and this one's going to repeat every 6 pi, so they will coincide every 12 pi. 4 pi and 6 pi both have common factors of common multiples of 12 pi. So that's how you can work out your wavelengths of when these will repeat, and how and what the period of these functions will be. Alternatively, and you can check that just by graphing it, but what you've got to realize is where the two wavelengths will coincide for the two graphs, and therefore where they will always repeat together. Right, that's the end of today's session. There will not be a session tomorrow, Tuesday. The next session will be Wednesday at 5 o'clock.